Hello friends, welcome back to your UPSC. So today in climatology we will be covering another topic, that is jet stream. So let's get started. So jet streams. What exactly are jet stream? Jet stream are upper tropospheric air circulation. That means this is our air and this is our troposphere. Okay. So these winds blow in upper tropospheric layer. Okay. So we can simply say that jet streams are strong and rapidly moving circumpolar westerly air circulation in narrow belt in upper troposphere. Okay, so they are strong, they are rapid, they are circumpolar westerly air circulation. Okay, and they have narrow belt. So these are jet streams. Now we will look into basic characteristics of jet stream. So the first basic characteristic of jet stream is it is found at the height of 7 to 14 kilometers above the ground. Okay. Second, its average length is about thousands of kilometers. Its width is about hundreds of kilometers, and its depth, that means its thickness, is about 2 to 4 kilometers. Okay. Generally observed between the poles and 20-degree latitude of both hemisphere. Okay. So actually we have studied tricellular meridional circulation. Okay. These were three cells, that is polar cell, Farrell cell and Headley cell, that we have studied. So on the convergence area of these cells, that is these cells, we have our jet streams flowing. Okay. Their circulation path is basically wavy or meandering. So they don't go straight. They have waving path. Why? Because of pressure gradients. Okay. So as the pressure gradients change, their path varies. So it may be like this, or at other season it may be like this. They are they experience seasonal changes. So how they experience seasonal changes? They experience seasonal changes in wind velocity. Okay, so during winter what happens is they are much stronger, and they are having much more velocity as compared to that of summer. Okay, and their maximum velocity ranges up to 480 kilometers per hour. The extent of jet stream is narrowed down during summer because of northward shift. See, what happens is during summer everything shifts northward. During summers in north During summer, as the sun will shift northward, the high pressure belt and low pressure belts will also shift northward, and hence these air, these winds, they also shift northward. But so what happens? The pressure gradient is lessened. So the gradient is lower as compared to the one which is in winter. Okay, so in winters the pressure gradient is more as compared to summer, hence the jet stream narrows down during the summer. Now as we have done the characteristics of jet stream, now we will look into basic types of jet stream. We have 5 basic types of jet stream, out of which polar frontal jet stream, subtropical westerly jet stream, and tropical jet stream are the most important one. Then we have polar night jet stream. Polar night jet stream is stratospheric subpolar jet. Okay, it is a stratospheric, that means it ranges above 30 kilometers. above the ground. Okay, and it is formed due to temperature gradient. So in stratospheric layer, the temperature is more as compared to the one on the ground. So there is steep temperature difference, there is more temperature difference, because of which there is steep pressure gradient, and thus the polar night jet streams are formed. And then we have local jet streams. Local jet stream are formed locally due to thermal and dynamic conditions. Okay, now as we have done the types of jet stream, now we will look into the formation of jet stream. Here we will basically concentrate on the most important three jet streams. Okay, so the first one is polar frontal jet stream. Polar frontal jet stream, it is formed above the convergence zone of surface polar cold air mass and tropical warm air mass. See, we have Ferrel cell. Okay, here we are having cold air mass coming from the pole. Okay, if we look this diagram like this, so here we have poles. So the winds are coming, air is winds are coming on the surface, this is on the surface, from the pole. So they are polar cold air mass, and from the tropical region we have warm air mass that is coming here. And here we have low pressure belt, subpolar low pressure belt. The wind rises up, and as the wind is rising, it diverges. Okay, so here we have studied, this is polar cell and this is Ferrel cell. Okay, this is polar cell and this is Ferrel cell. Now see, this wind is rising. Now let's concentrate on this wind. So this wind, when it rises, it diverges towards the axis of rotation. So it is diverging towards the axis of rotation, because of which the radius decreases. Why it diverges towards the axis of rotation? Due to Coriolis force. Okay, so in northern hemisphere it diverges towards its right. Okay, so it diverges towards its axis of rotation, thus decreasing the radius. And according to the conservation of angular momentum, the law of conservation of angular momentum, the radius and velocity, they are inversely proportional. So as the radius decreases, the velocity will increase, and as the radius increases, the velocity of the thing will decrease. Okay, so now here the radius is decreasing, hence the velocity will increase. Okay, just a second. And because the and now the velocity is increased, so we can say, due to decrease in radius, or due to lessening of radius, the velocity of the jet stream increase. And these jet stream are the strongest one among the all. Okay, amongst the all, their speed is 130 kilometer per hour in the winter, average speed, and their average speed in summer is 65 kilometers per hour. Okay, so they are much stronger in winter as compared to summer, but they are irregular. That means they are discontinuous. Why they are discontinuous? They are discontinuous because if the pressure gradient is not suitable for formation of this jet stream, then they are not formed. Okay, so that happens in the northern hemisphere, where the pressure gradient sometimes becomes very low. Okay, so these jet streams are not formed. Next we have subtropical westerly jet. Subtropical westerly jet, they are also formed in the same way, but the difference is we have polar and ferrule cell were here, but here we will have ferrule cell and Hadley cell. Okay, so towards the poleward limit of Hadley cell, that is this side, and in southern hemisphere also poleward limit of Hadley cell, we will have this subtropical jet stream moving in the upper troposphere. Okay, so it basically runs in 30 to 35 degree latitude, and this one runs, that is polar jet stream, polar frontal jet stream, it runs in 40 to 60 degree latitude, north and south. They are regular. Okay, but sometimes in Asia, because we have tropical jet stream in Asia, they are replaced by these tropical easterlies. Okay, but that happens only in Asia. Otherwise, all over the world, rest of the world, they are continuous and regular. Lastly, we have tropical jet stream. Tropical jet stream are actually upper tropospheric jet stream or air circulation. They are above the surface easterly trade winds. Okay, we have surface easterly trade winds over India and Africa during the summer. Okay, and they are formed due to intensive heating of Tibetan plateau, and they play important role, very important role in the mechanism of monsoon. Now, how it works, how the tropical jet streams are formed, and how they help in Indian monsoon, that we will study. So, in the last class, we have studied Indian monsoon, where we have studied that the subtropical jet during winter, its one branch gets catch or get trapped, that is south tropical jet, it gets trapped in the Himalayas because the Himalayas have the lofty peaks, and their height, it traps them, and they are not able to move upward. So during summer, what happens, we have this Tibetan plateau here. Its height is 5,000 meter on an average. Okay, and it is made up of amphibolistic granite. So amphibolistic granite, it has a tendency that it gets heat up very faster, and it gets heat up very much. Okay, so during the summer, when the sun shines, okay, this area does not have any vegetation, so this is vegetation free, and its length is more than 2000 kilometers. So when it get heated up, this area, when it get heated up, it gets heated up very intensely. Okay, and because it is getting heated up very intensely, the air mass above this area, it rises up due to convection. Okay, so the air is rising up. So when here we have Himalayas, in which the south tropical jet was trapped. Now because the air is rising up, it actually lifts the jet stream, that is subtropical jet stream, with itself. Okay, and because of this lifting, we have these two branches, they are also lifted along. Okay, so the south tropical jet is also lifted along, and as soon as this south tropical jet is lifted, it shifts northward, and as it shifts northward, this is India, ITCZ, it occupies its area. Okay, so now we have ITCZ here. Now as the ITCZ is here, that is the low pressure belt is here, the high pressure belts, the southern high pressure belt, they also shifts upward. Okay, so this is our Tibetan plateau. We have Himalayas here. India, then we have Indian Ocean. Now here we have Madagascar and Mascani Islands in African subcontinent. Now the high pressure belts, they have reached here because we have low pressure here. Now, as these winds have rised, they rise and they diverge into two. So this branch is known as tropical jet stream, also known as easterly jet. Now this jet stream, because we have, just a second, because we have low pressure on the surface, we will have high pressure in the upper atmosphere. And because we have high pressure here, we will have low pressure in the upper atmosphere. So wind always moves from high pressure area towards the low pressure area. Now, the wind is moving towards the low pressure area. Okay. And this wind, which is moving towards the low pressure area, it subsides down as it reaches here. And because it is subsiding here, the high pressure on the surface, it intensifies. So till here we have learned how the tropical jet was formed. Now how it helps in or how it plays an important role in the mechanism of Indian monsoon, that we are studying now. Okay, so as it moves downward, it was already a high pressure area, but due to uh, settling down of air mass in this area, the high pressure intensifies. So now what happens? The winds that were going, this is our equator. Okay, this is 0 degree equator. Now these southeast trade winds that were moving, they move with much more velocity, and as they crosses the equator, due to Coriolis force, their direction changes towards southwest direction. Okay, they changes their direction towards northeast direction, and they are known as southwest winds. Okay, and these southwest winds are also known as monsoon winds. They actually carry, they are warm and they carry humidity as they, and they carry moisture as they move from the ocean. Okay, and they bring huge amount of rainfall in Indian subcontinent. So these were tropical jet stream, and this was the process that how they helped in Indian monsoon, and that was the process of formation of tropical jet stream. So these jet streams, these tropical jet stream, they replace the subtropical westerly jet stream during the summer due to this mechanism. So that was all for today, guys. I hope you enjoyed today's lecture. So let's meet in our next class. Till then, take care and have a nice day.